Hello. And there it is. What we're gonna be doing today. Poster on my wall. Totally a poster on my wall. Definitely a toaster on my wall. There it is. And the dog with the eval and apply yin yang on his face. I believe it is time to eval and also to apply. I believe it is time. I am prepared, though I'm not entirely sure how to do it. I'm gonna find out. Hello, hello, hello from Brazil. Hello, welcome. And a hello, Dulce. It is time. I hope you're excited. I've been waiting. There was a slight chance I would have to cancel the stream. And normally I would have just left it for Friday, but if I really had to do that, which obviously I didn't, I would have just done it tomorrow. That's how important this is. That's how excited I am for this. You crying? You're good? You're okay. Alright. Let me know if you have if you need anything. Alright. Okay. Wait, speaking of which, am I able to move this? Fucking OBS, man. Remember when software used to work? I used to be able to edit things by dragging them around the canvas on OBS. Now I can no longer do that. So, that poster's just gonna stay there, okay? I can't be bothered moving it. I cannot be bothered with that. Hello, Lexical. Okay. What is eval? What is apply? And why are we doing it today? Don't ask me, I have no fucking clue. I've tried twice already to comprehend these functions, and I failed. Now, okay, I get what they do, but they are the two fundamental functions for Lisp. Do we have a formal definition of them? Because I totally know it, but like, it would be nice to know. I usually am pretty good at clicking on the second link instead of the first one. This time I failed. My bad. I'm surprised there is no specific description for these functions in the Wikipedia article for Lisp. But don't matter. It's all the same. Lay out your arms. Here it is. Actually, this is the article that I've been like using to read code for a Lisp interpreter for like a week now. Less than that. And I haven't bothered actually going through the article. Yesterday I tried finding out who wrote the article. I couldn't really. It was someone who runs this programming praxis blog. Don't know which one exactly. There were two people listed. Anyway, it is an article that they wrote when the creator of Lisp, John McCarthy, died on October 23rd. Well, they wrote it on November 1st, but they wrote it as a tribute for the creator of Lisp. And as a tribute to the creator of Lisp, they wrote a Lisp interpreter explaining all the parts of the Lisp interpreter and telling people how to implement one, or telling people to implement one. Have I tried i3 window manager? I have. Probably will start using a window manager eventually, but yeah, couldn't really be bothered. Feels like a hassle. Anyway. McCarthy defines the eval apply yin yang that is the heart of Lisp on page 13 of the Lisp manual. I'm not sure why everyone references the Lisp 1.5 manual. You would think the 1.0 manual would be the first one, the OG one, but no. But even then, like, I did read a little bit of this, and it does talk about things that aren't really part of Lisp, haven't really been part of Lisp. They were part of the, like, theoretical part of Lisp, but they never, I don't think, made it into the language, such as this syntax, which is called M expressions. It's closer to what we C programmers and C-style programmers know as functions and whatnot. Right, you have the EQ function with this argument and this argument. Slightly different than how Lisp does it now. Same words, just with parentheses. They have semicolons to separate the arguments. Like now, semicolon is actually the comment in Lisp. So there was this whole like discarded theoretical part of Lisp that was supposed to be that these expressions are how humans write code, and then the S expressions is how the compiler understands them. Well, the interpreter understands them. But I don't think that ever was done like that, and then eventually it was discarded. I think it was never like that. It was just theoretical, but I'm not sure. So but it is still a little weird to see it being used in the 1.5 version of the manual, so I'm not sure what's up with that. Anyway, Lisp 1.5 was the first widespread from MIT. Lisp 1 was very basic and not really Lisp yet. Yeah, I figure. No, I understand that. It's more so about like that kind of stuff. So yeah, I understand maybe even Lisp 1 is not even, like, the manual may not be available or even have existed back then. Wait, hold on. The Lisp 1 manual by Patricia Fox was dated 1960, which is usually cited as the birth year of Lisp, even though Lisp was formally specified as early as 1958. Okay. Well, anyway, the two functions are eval and apply. So apply is going to take an expression and interpret it. No, interpret it. Where it essentially handles three possible cases. I'm assuming further specifications of the language can be slightly more complex than this, or even just use different words and whatnot. But essentially, this here handles built-in functions. Char, CDR, cons, atom, and EQ. And then the final case for non-built-in functions, it just calls apply on that. It calls apply on the evaluation of that. So makes it a little bit recursive. If it called apply with the same arguments, that would literally be an infinite loop. So yeah. It also handles lambdas and labels, which, if I'm not mistaken, from what I did understand when I tried to understand this the code the first time, is just what handles like function names and whatnot. All right, the first clause dispatches one of the various built-in functions of Lisp, calling the underlying language, in this case Lisp, since this is a meta-circular evaluator. So yeah, this is a Lisp interpreter in Lisp, so it's not super helpful, but essentially, you know, if it's car, then use the built-in function of car, the functionality of car, the built-in functionality of CDR, the built-in functionality of cons, so on. The second clause evaluates the functions defined by lambda calling eval. Right, so if there is a lambda, then you evaluate the body of that lambda using this. And the third clause is special. It evaluates recursive functions defined by label by first adding the function to the environment, then calling apply recursively to evaluate the new function. Apply uses an auxiliary function pair list to insert function definitions into the environment. As an example, well, I'm not reading this whole thing. Thank you very much. All right, but essentially, yeah, it's what allows to define functions with a name by adding them to the environment and then evaluating. Same as you would a lambda, which is just an anonymous function, but now with a name. Then there's eval. So that was apply. It takes these expressions, function calls and whatnot. And then there's eval, which handles statements, which are known as special forms in the parlance of Lisp. In a function, the element of the expression are all evaluated before the function at the head of the expression is called, but in a statement, order of evaluation may change. What? Well, essentially, it's evaluating the body of a function. That's what you're saying. If an if statement, in an if statement, only one of the two consequences is evaluated. Okay. I understand what you mean. So yeah, it evaluates the actual body of the function, whereas this evaluates the structure of the function, if you will. That's how I see it. That's what I understood from this. And eval handles two special forms, quote, which handles its arguments literally rather than evaluating them as expressions, and cond, which executes conditionally, checking the predicate of each clause until it finds one that is true, then it evaluates that associated expression, and it uses three auxiliary functions, which, yeah, no need to explain them to understand the logic. All right. So, yeah, what I understood from this is when you have an expression like hello, the entire expression gets evaluated. The first thing that happens is this gets checked against these possible values, which are built-in functions. If it's none of those, it will evaluate the arguments of the function and then apply the function with the evaluated arguments. No, sorry, never mind. It evaluates this. It evaluates this, which essentially results in going to the environment. Is there something called print? There is. Okay, what is it? It's a lambda, but with a name called print. It's a function, essentially. All right. So it gets that and then passes the arguments. So this becomes something like, lambda with the implementation of this and whatever, well, the arguments, which is like the string that gets printed, and then how to actually print. I don't know how that's implemented. It doesn't really matter. Point is, evaluating the word print results in, getting the lambda from that. And then this whole thing gets evaluated. Now we have a lambda, which gets evaluated differently. This time it actually calls eval on it. So now it actually resolves the function. And when I looked at the Python implementation for this thing, it became a little bit more clear. Essentially, it's going to create a new environment where str has the value hello, and then evaluates this. Where anytime the str is used, that gets evaluated, checks the environment, finds hello, that's how it applies the function. Look at that, I understand the Lisp interpreter. The stream is called Exploring Programming Languages and Making a Lisp Interpreter, so I should fucking hope I understand the thing that I'm gonna be implementing. But hey, we did it. We did it. I struggled a lot on Thursday, and largely because I did not bother reading this thing. Then after, I think it was Thursday or Wednesday, one of those days, after that stream, I ended up reading a little bit of the Lisp programmer manual. If I'm not mistaken, it's something like 100 pages, so I didn't read all of it. 116 pages. But yeah, I did start reading a little bit of it and understanding a little bit more, but literally could have just read this paragraph, and I would have understood everything that needs to be done. How hard would that have been? Anyway, did I go to university? Unfortunately, yes, I did, but I dropped out. It was a pleasant experience. It was not bad, I just didn't like it. As an experience, it was okay. As a thing that I enjoyed doing, no. Okay, so take an expression, give it to apply, evaluate the body of that expression till everything is applied, until everything is evaluated, the whole loop. There you have it. It's almost as if the wizard guy on my wall has been telling us the whole time. Yeah, it was for CS. Okay. So, what I have right now is a very basic syntax of Lisp, very minimalistic, capable of handling the bare minimum. It doesn't handle quotes. It doesn't really handle... How far can I take it? How far can I take it? Actually, I want to see. It can handle something like this. That's a good start, I guess, for a lot of yapping that I did yesterday in like an hour of coding. So now I can handle this. It can handle nested expressions correctly, which, by the way, it always handled nested expressions correctly, but I am printing. By the way, I updated it to the new build system. So now it's actually building with Lisp. To check that I'm doing everything correctly, I am printing out the result of, well, I'm printing out the program that I get as input back as output, and I'm printing everything on a new line, so it can be a little bit hard to read, but we have beginning of an expression, print, hello, then world. 2 words right there. Close the expression, new expression, print and world. Print 2. I did it like that to make sure that I was doing them differently. Then print 3 in its own expression, which contains another sub-expression, print 4, which contains hello world, because I misspelled it, I'm not very good at typing. Then close both expressions, then print 5, yo. It's nonchalant like that. Let's do another thing I didn't check is what happens after the sub-expression. Can we handle the other arguments correctly? And the answer to that is yes, thank God. Okay, so here print 4, then hey, then print 3 ends. Okay, so again, a little bit hard to read with the print instead of put, but it works. Masters right now, but thinking about dropping out to have more time to code projects I'm interested in. Isn't masters after undergraduate? You can understand why I dropped out and why I did not like the academic part of college. Is it noticeable? I barely even know how the damn thing works. To be fair, I went to college in Italy and Venezuela and Spain. That was the whole thing. Okay, so it can handle expressions like these. Can it handle lambdas? I think it can handle lambdas pretty well. Maybe if we call them lambda like that, and then we give them, you know, a body hello, and maybe we even give them an argument str, and then we do str. Okay, compiled. We have expression, lambda, sub-expression, str, sub-expression, print str, close, close. Correct. Okay, so lambdas at the very minimum will work. Now, what will not work, and this will require a little bit more hands-on work, especially in the tokenizer, because the tokenizer is built to tokenize C code specifically. It's hard-coded for that, and I would like to make it more dynamic. So while I probably could make it work, it's not a good idea. There's a little bit of special syntax in Lisp, like this kind of character, this kind of character, which, by the way, I don't know why I thought this is just shorthand for make this into a list. That led to me having issues last week. I don't know where I learned this, but I must have misunderstood something. I was under the impression that this just is shorthand for make a list. Maybe I read some code and I thought that's what it was doing, so I just like created that association in my brain. I don't know. Creating an association in your brain, kind of like a linked list. Lisp would have been perfect for that. If my brain was written in Lisp, this wouldn't have happened, I can tell you that much. But yeah, there's this kind of expression. There's back quote expressions, which I'm not entirely sure what they are. I just know that I have to use them in macros sometimes, and I just look up a macro that I wrote in the past to write a new one with this thing. There are also things like these, and even this. So if I'm not mistaken, let's learn. Lisp back quote meaning. Okay, so back quote is the same as the other quote. Because back quote basic is the same as quote basic, that is quote basic. For any expression basic that is not a list or general vector. Search real takes on every topic. Sign up or I already have an account. Where's the go fuck yourself button? Reddit, after Stack Overflow died, you're all we have left. Please, fuck right off with that kind of bullshit. Okay, so apparently this and this are the same thing. I guess that's why I didn't understand. And I know that this, using a comma before that, actually evaluates this expression. So this means quote. Essentially, this literal thing is the value of the thing. Not evaluate the expression and that's the value. No. This print str is the value. However, when you use the comma, it does mean actually this one you do need to evaluate. So not the words str, but the value of str. That's my understanding of it. Either way, it doesn't really matter because we're not ready to have that kind of syntax yet. Another thing we cannot have is this, where it's not really valid Lisp syntax to put this here, but like something like map car with something else here, essentially means map, the functional programming function map, essentially for each of these elements in this list here, assuming that this is a list, run this function passing the element as the argument to the function. And this is just used to mean, you know, the function called fn. It's passing the function as an argument. Again, we don't have these, and we don't have these, so not syntax that we can support. And another kind of issue is that some functions in Lisp, Lisp is very lenient in what can be considered an identifier. For example, this is an identifier. This is an identifier, and this is an identifier. Whereas in C, none of these would be valid. The closest would be this. And again, because my tokenizer is for C, it wouldn't be able to recognize these as an entire token. And I would much rather, again, work on the tokenizer, rework the tokenizer eventually, and introduce those once that's ready. I mentioned the other day that I wanted to look at programming languages that are used for string manipulation, for, text processing. And so that's a good excuse to do that, to replace the tokenizer with something more flexible. Okay. To be fair, my tokenizer works really well for most C-like programming languages, but I'm working off of the other branch of programming languages. Like all programming languages either inherit from C or from Lisp, and usually a little bit of both. But like tokenizer works for all languages that are here, but it doesn't work for the languages that are here. And I'm trying to parse this language here at the root. So that doesn't help. Anyway, we can do lambdas. We should be able to do something like defun with a name of a function, arguments of a function, and the body of a function, bedoy of a function. So assuming that this is parsed correctly, then defun begins here. Name argument is a sub-expression, bedoy is a sub-expression, and there it ends. And of course, there can be bedoy2. Oh my god. I actually tried misspelling body again as bedoy, and I spelled it as body h. Does anyone know how I can learn how to type properly? Because Jesus fucking Christ, I'm so bad at it. Okay, defun opens here, that's the name, that's the arguments, that's the body 1, body 2, and close of the expression. So, we're good. I'm basing my syntax off of Common Lisp. I do like that. I've looked at some others, there's some things that I don't particularly like. Actually, that blog that I'm looking at, Rip John McCart, this is such a grim name for an article, but I understand where you're going from. This one, they wrote in Scheme, and really all it took was just change define to defun. The rest, I think, stayed the same. Did I have to make any more changes? I don't think I did. Maybe the equal turned into an EQ? Not entirely sure. But yeah, I'm still basing everything off of Common Lisp. Now, I separate namespace. Nice part of Scheme is just being able to do map square instead of using the hash quote syntax. Is a Lisp 1 or 2? Couldn't tell you, to be honest. Again, I'm basing my syntax off of Common Lisp. You know, one thing that I did find very annoying when it comes to namespaces in Common Lisp? For example, let me go to my build system. Right, so my build system has a package called red build. The red build has a function called quick build, but that is within the package red build. If I try to do this, it won't compile. And it will tell me that Common Lisp user quick build is undefined, because the only package that I currently have loaded is that one. So I very much need this here. I think I can actually like find a way to put myself in the package and not need these, but I don't remember how to do that. But let me define a function called quick build. That works? No way. Maybe I'm wrong about what I thought. Yeah, that compiles. Why did I think it didn't? I must have again misunderstood something that was happening as a different kind of bug. Okay, so never mind. Separate namespaces with packages, I like that. It allows you to have globals and it allows you to have non-globals as well. Kind of, you know. Everything's in a package as long as you're within the package. Everything is defined within that namespace. So I like that. I like that. I think namespaces, like separate namespaces, are particularly easy to do in Lisp because of the way that it uses the environment. But I guess we'll see. But I do plan on having it like that. Separate namespaces is usually a good idea. Okay. All right, so I called this function eval, but now I need to think, is that really what I want to do? Do I want this to be eval? I'm not sure. Why? What this function does is it just gets the next node on the list. Shame, Peter. I mean, hi. I still find it so funny that Haya gets translated to shame. What language does Google think it is? Does YouTube think this is? Does it tell me? No. Okay, in what language is Haya shame? In none. You know what's really funny? This is Google Translate. And the one that's having the issue, I see it on my laptop and on YouTube chat, but not on OBS, so I can't really show it, is that this gets translated to shame. Shame. But Google Translate doesn't do that. But YouTube Translate does that. They're the same company. Why is your translator not able to work properly? Is it a different translator? Isn't the obvious solution, hey, we're YouTube. Our parent company is Alphabet. You know what else they own? Google Translate. So if we're going to be adding translation to our company, to our chat, we should probably be doing it with that. Isn't that just a logical way of thinking that everyone should use? And who is responsible for not having done that? Why are there two different translators, of which one of them is clearly a local LLM and the other one is Gemini? So at the end of the day, translators are usually powered by transformers. I'm not sure if it's the exact same thing as, you know, the chatbots, but they are usually powered by the same technology, and it's one of the few uses that this technology has. You know, language handling for the language model. Like actual language, not a language that is actually just logic hidden as language. Anyway. Okay, so we have this function again. Not sure if the name of it should be eval or not. Right now, what it's doing is it's just getting the next node, and I have to make it get every next node. Whereas before it used to just... So actually this for loop is doing nothing anymore. This for loop is useless now. And it's just making the syntax more difficult. All right, all it's doing is getting the next node and seeing where expressions begin and end, and seeing where they have what I call a semantic value based on the rules of the language, which are... I'm looking for lisp.rules. Where is that? It's in languages, actually. I moved it all over here. Yeah. S expressions get marked as expressions. So when one of these is found, we consider it to be, an actual expression. So parenthesis, close parenthesis. And atomic expressions are also considered to be expressions. So where one of these is found, it's printed. That's how we get this. However, that's just walking the node, walking the tree. It's not really a tree, it's a stack, but it doesn't really matter how it's shaped. It's an abstract syntax stack or abstract syntax tree. In the code, I actually still call it an AST, but I kind of regret it. As node would be much better. And actually, assignments in the code generator are called, where are they? No, in the IR. Assignments in my IR are called as code. So as node wouldn't really be out of the realm of possibilities. But anyway, the question is, do I want to use this function, this structure, to immediately start evaluating functions, or do I want instead to transform it into an intermediate representation and then do it over that? I feel like that would be a lot easier because it would be way more structured. So writing the interpreter would be a lot simpler. And then it separates the parsing from the evaluating completely. It seems kind of wasteful. So I'm not entirely sure what I want to do. It seems like that is more of an IR generator, like an intermediate representation generator, which is what a real compiler does, whereas here we want to have an interpreter. So I'm not sure. But I like the idea of having stuff more structured, I guess. Oof. I guess, alright, let me see how far I can get with doing it directly from the AST. Alright, so the first function that I would be called in, what expression do we want to evaluate? We want to evaluate, what expression do we want to evaluate? It's a very simple one. Now that I know that my parser works and recognizes the structure correctly, I'm going to want to evaluate, how about, let me see, something that I can also see, like what I'm expecting to see. For example, print. Well, no, can I just do car? Can I do this? No, that's not valid. But I can do car list 1. Or a very simple expression is even something like this. The problem is that's technically not super possible to do because of the symbol plus. Keep the parser and evaluator separate. So make a structured form of the program and then evaluate over that. That feels cleaner. Yeah. It definitely feels cleaner. I'm still gonna try to run over the logic of how would I do parsing of, yeah, even this expression is fine. Just for, I'm not actually gonna build it. And I could just change the word, change the symbol plus with add. It's fine. And then eventually, once I have a better parser, do it properly. Anyway. Okay, so this is the expression that we're going to be getting in. We're going to be getting it in the form of an S expression. Well, hold on. Let me actually put it in the code. Add 1, 2. I'm still in the sabbatical. All right. This is the expression that we get. The first thing we run on this would be to apply. Although eval quote is the entrance to an evaluator, which really is just apply. So, yes. All right, so I have add 1, 2, and I run apply. What does apply do? The first thing it does is it gets the first element of that. Can I easily get the first element from the abstract syntax tree? Not super easily. See, I used to have it so that it would yeah, no, it's better to do it because of this actually. So yeah. Yep. I'm gonna build an actual language and then use that. So I'm gonna be using the same thing that I did for my intermediate representation. Italian living in Germany. The Italians are living everywhere except for Italy. I say as an Italian living in Spain. Okay. So this is the IR used by C. For that matter, how much of this is actually reusable? We have BLK code, which is not black code, it's block code. It contains a statement and then something after it. This is essentially in Lisp syntax that. So even just that could be reusable, as long as I haven't hard-coded too many rules for how it works. But even that, those rules are hard-coded for C. This is for Lisp. We're using entirely new code. Even if I use the same structures, the way that they work can be different. Let me see. Yeah, no, these are hard-coded. Okay. I would rather do a language specifically for Lisp. But anyway, we have block code. We have declarations over here, ask code, which stands for assignment, arguments for a function, which are also chained. So you can see at the end of the day, a lot of my syntax is just chained. This is very close to the actual language, because the language that I am compiling is... This is the Italian version of it, but, you know, very similar to C. And the output of it is C code, so it helps me that this is specifically for that. Now I did create, okay, here they are. There is a rule language for the parser, and that rule language uses its own IR. So, can you do pragma section? Is that a thing in C? I remember there being something like that in Objective-C, but I don't remember if C does it, and also if that was the syntax for it. Is a directive in C? Pragma section, and then it has that, and it says read write. What? Wait, what does it do? In an OBJ file? No. Oh, no. Is it pragma mark? I remember writing that at some point. It's an Xcode specific thing. That's interesting. I did not realize that. It's an Objective-C thing, which, by the way, C with classes is Objective-C, not C++. C++ is C with bullshit. Anyway, pragma mark in Objective-C is, you use that and then you give it a name, and it does this in your code editors, well, Xcode, because it's made specifically for that. But in your code editor's organizer thingy here, it just creates a section. Right, so unfortunately we don't have that. Oh, very sad. Speaking of which, Lisp uses this syntax for a list processing language. Is there a... I know that it calls them as expressions. Is there a more common name? Like, are there other languages that have similar syntax to Lisp and also have, the same kind of... I know it was influenced by IPL. Did IPL look like that at all? What did that say? Oh, can't generate AI overview. Okay. I read can't ignore. A Mandra protocol language. No, that's not it. Information processing language.
Fossenlicht readied your channel with 3 viewers.
Fossen? She's still talking? I wasn't wearing my headphones. It's not like I play music, so I take them off. Alright, Foss Unleashed. Thank you for the raid. Welcome, everybody. You're here just in time. For whatever the hell I'm doing, actually. Here just in time for anything. I'm just seeing the syntax of Lisp and starting to write my Lisp interpreter. Very excited about that. Very excited about that. And I was looking at the information processing language here, which is a precursor to Lisp, but it does not use the very similar syntax. I was wondering, I'm going to be creating an intermediate representation inside of my interpreter for Lisp style code, but it doesn't necessarily have to be linked to Lisp, like maybe other languages with similar syntax, but I feel like the same syntax wouldn't really work for other non-Lisp based languages, so maybe I should just call it Lisp code, and if I ever end up generalizing that name, I'll come up with it. Yeah, no, this is Lisp. It's just that it says that Lisp was influenced by the information processing language, so that's where I was going with that. Essentially I was saying, are there any languages that have different paradigms but similar syntax to Lisp? And I don't think there are, because again, I feel like the syntax to Lisp is very Lisp based, so it kind of goes hand in hand with Lisp. Hello, Anj. All right, slang. What is slang? Oh, hold on, I don't need a page for Lisp. Is a software library for Unix, Windows, VMS, or VMs, or VMS? OpenVMS. Never heard of it. OS2 and macOS, it provides routine embedding of an interpreter of the slang scripting language and components to facilitate... Okay, but I asked about the language. Is it S? Here. No, this is source code. Oh, it actually looks like that. Okay. Okay, so yeah. Again, the syntax of list. My God. is literally, the syntax of Lisp is literally perfect for Lisp. Not sure it would work for other languages. So I'm going to call it Lisp code. And I'm going to be writing S expression code. And I don't need atoms, actually. This is literally all I need. And now I can stop calling them sexp, or sex expressions, because I am clearly putting a delimiter between the S and the EX, which I have had issues with in the past. Moved to Germany for love, nice. No, I like, Italy's okay. I've had my issues with that country, but I do like it. To visit especially, but to live there, not so much. Okay, what is an S expression? It is made up of... Okay, so I do kind of need... No, actually, you know what? I can do something like this. A little bit of redundancy, but... Okay. So again, concept of car and card. The concept of car and CDR. Oh my god, I cannot speak today. Car is the first element of a list. CDR is every other element in their own sublist. Right, so this is car. This is CDR. And if you try to get the CDR of this list, you will get this. You will get a list containing 2, 3, 4, 5, 6, 7. I just realized I skipped 5. Alright, now you will. And I am doing a little bit of redundancy here, for the sake of it, to check for, well, to hold the two possibilities. That car is an expression in and of itself, and that it's a token, or an atom, as it's called in Lisp. Right, because in this case, car, the first element, is an atom, it is the number 1, whereas in this case, car is the list containing 1. Its car is 1, but the car of the whole thing is a list containing 1, so it would be this one, right? Because it's supposed to chain. I can make it more explicitly chained, because but there's no need for that actually, because the entire point of this code, which by the way I should have rewritten in my language now that I can, but this is the compiler for that language, so it's a little bit scary to do, though it already has some parts that are generated. The whole point is that every single one of these structs conforms to a code gen interface. Don't remember if I ended up building all the elements that I needed for it, but I think I did. Looks like two communication protocols and WebAssembly use as expressions. If I recall correctly, the cryptographic X501 or something format has expressions as well. HDTL? What is HDNTL? Who uses that? Head and tail. Head and tail. That's very fair. I'm actually gonna use that. Yes. HD and TL are from Limbo. The video game, or is there programming? Okay. Uses Ada style definitions like this. Oh, so does it just use it for its lists? Not for the whole length. Ooh, OS Inferno. I was talking about Inferno yesterday. I was mentioning that when I build a time machine and we go back to 1992, I believe was the time that I established. before the creation of JavaScript, before the creation of PHP, before the creation of, before the widespread implementation of TCP/IP, and we do everything correctly this time around. Also before Linux. Then, oh no, never mind. Linux was 91. We can do things all over again, and I was talking about how Inferno lost to Java for some fucking reason. Pretty sure because they both use VMs. I genuinely don't see the association between an operating system and a programming language as competing against each other. Besides, they both use VMs. Don't really get it. Anyway. Did I do Holy C already? Only in the terminal. I haven't really done a whole Holy C. Writing anything in Holy C, no. That hasn't happened. Very Microsofty, honestly. I didn't like the language. Inferno's VM. I actually don't know how Inferno works at all. I've looked at Plan 9 extensively, but not in Inferno. I should probably do that. Let me leave a tab open for next time I explore some other operating systems. So most of the time on these streams, I just build an operating system. Sometimes I explore programming languages. Sometimes I explore operating systems. Sometimes I work on a compiler. Anyway, sexp code init. All right, so I'm gonna need to write a little bit of boilerplate now that there's technically a new type. But well, luckily some of that boilerplate is already taken care of for me. SXP code using a semantic rule of expression, actually. So when well, this is not actually gonna be used. I'm gonna be building it a lot more manually. Well, I do wonder actually. Could my IR generator build this thing for me? Worth a shot, I think. Maybe I won't need the Lisp specific interpreter at all, but I guess we'll see. Thing is, I might need some adaptation. The IR generator is made in a manner that it should be able to generate an S expression in this format that I'm just defining, as long as, I keep forgetting where I moved the language, as long as S expressions are tagged as such. So I should be able to handle that just fine, but I don't know if it's going to be able to handle this just fine. Inferno's VM has the concept of processes. A single VM instance can run multiple processes. Each different disk files. It also provides a semi-virtualized file I/O interface. It is a programming language at the end of the day. It is a operating system at the end of the day. All right. So yeah, using these functions, it should be possible to build them automatically, but it might need some adaptation, or there would be too much redundancy for my liking. Especially redundancy that makes it not easy to work with. But this function will get called when a token is found inside of this S expression, and that will never be the case, actually. Yeah, so okay. Probably better for me to leave the whole generate the structure of the program automatically part for later. Otherwise, I risk wasting too much time on that and not actually getting to the interpreter part of this. So I'm going to do it manually. Best case scenario, I get to get rid of this entire file eventually. All right. There is, I believe, some more boilerplate I might need, but I don't think I need it right now. I do. Because you want SXP code emit code, right? This is for the C code generator, which I would have to use something like this. Okay. I do need these functions, but I'm going to switch it to using the rule generator. Well, whatever. I'm going to do it in the C code. None of these are actually going to happen. And there's literally only one case I need to handle, which is the S expression code emit code, which will do nothing. And I also need an S expression code transform because I'm doing transformations on code. None of that is actually necessary in Lisp. That's how great this language is. I'm just adding boilerplate because the compiler requires it, and it would be too much time to get rid of that. Undefined reference to SXP code transform. I just added it. None of these are going to be called anyway, but which transformer are you using then? This is the rule generator. Oh, wait, no, the rule generator also needs the same boilerplate. That's what you're complaining about. So here you go. This is one thing that kind of does suck, is that I can have different, currently they're different languages entirely, like different intermediate representations. They don't necessarily have to be, and kind of the compiler doesn't treat them as such. I have an intermediate representation used for Lisp, I have one used for my rule language, and I have one used for C, and it kinda I knew you were going to complain about that. It kind of requires you to implement all these functions in all of them. Even though these functions are guaranteed not to be used. These functions are guaranteed not to be used by Lisp, and these functions are guaranteed not to be used by others, but now I have two definitions. No, what are you complaining about? Multiple definitions of SXP code transform. You just told me I had no definitions, so I defined it. In rule transformed, it says that it was first defined in rule code gen. Oh, wait. Emit code. Yeah, you got a point. My bad. All right. So there, compiler is satisfied with the new rule that I added. Now I can actually start doing some interpreter stuff. Okay. So, the way that I built this function, which is a walk AST function, it is no longer the eval function. We'll get to it, but this is not it. What this does is it is going to be creating an S expression which you're going to need to include from ir/general. There you go. And here's how it's going to work. Whenever we begin an expression, which we're doing right now with a parentheses, we're going to create a new S expression. How do you do this? I believe there were some custom initializers. I need to remember. I have an entire like meta programming language going on here to do transformations on code, move stuff around and like generate code and whatnot. It's not as beautiful as it would have been if it was done in Lisp, I can tell you that much. Begin rule. That's how you do it. Begin rule. Begin rule, where the rule is of the kind expression. Ah, no, that's, I can't really do that. Can you please go to the function? Okay, so I'm not gonna be using this stuff. I can instead just call a function that is auto-generated called sExpression code init. That is going to create a type of code gen. And that one's what gets passed down here. Okay, so we generate a new code, and then we should be able to do sExpression. What did I call that function? Register subrule, in order to save that function, or save this thing into the existing one. God, all this jumping around is so bad. If the world would be much better if more things used Lisp, yeah, that's definitely true. All right. Why are you not finding the function? Call to sExpression code register subrule. That exists, my dude. And guarantee you they exist, okay? Again, I'm hacking everything together here. I'm gonna have to do it properly. I'm going to want to do it properly, but right now, I don't want to waste too much time on writing code properly. I want to just get to it. Otherwise, yeah, I'm gonna be streaming forever, or I'm not gonna get anywhere. So okay, register subrule. Type literally does not matter, and the child is new code. So this will append this thing to, or the result of this thing, as the next node in the sExpression. That's not enough though. Okay, I'll figure it out in a second. When the node has a semantic value that is not an expression of type expression, then this is simply an atom, the only other possibility we have right now. So we can save that. ESXP code register element code 0 node T. That will save the value of the current node. Actually, yeah, I should be okay with this. All right. And that should be it. When a sub-expression is created, we're going to get that sub-expression. We are going to register it or to process it, calling this function recursively. We're going to put it inside of a subrule here. And same thing here, but with tokens. All right. So now for implementing these functions properly, the IR generator cannot handle this for us, is the thing. Because the type is not what matters, the order of things is what matters. So this is an S expression. See some code. Yes. So I need this. And well, I actually need to use the correct value here. exp code s exp code. We're trying to register a token in this thing, and it's pretty simple. We have to check if the code car is assigned. If not, we are going to assign it as a token type of car. That's lm. And that is it. Do we need to return? No, wait, there's no return types in this. Okay, that's literally it. And here we have to do that with the child. All right, so that will put the first element inside of the current inside of the current S expression. Then we're going to check if there is a second, if there is a secondary S expression. So if CDR exists. All right, Jester, what's going on with your ear now? All right, I'll be right back. Okay, had to do some maintenance on the dog. Anyway, we're back. Well, I'm back. He's not. Hold on. Let me put a replacement until he gets back on the bed. You know, once you stop staring at me, you can just come in, you know. All right, so we have logic for assigning the first element of an X expression. We now need logic for if there is a next part of the S expression. At this point, my camera view is mostly just images. It's not even me anymore. I'm just gonna put up an image of myself and not even turn on the camera next time. All right, if there is an existing CDR, then we just defer what we're currently doing to it. It's gonna be the one to handle it. And even though we're not using this token thing, this type thing, we're still gonna pass it on. Same logic goes here. only the name of the function is subrule and child. And then there is the other possibility. We don't have a CDR. In that case, we're going to have to create it. And then we're going to do, will we get to that case? Yeah, if there's two atomic values, yeah, this can happen. Okay, so we're going to create a new S expression. These functions are very, very similar to each other. I'm sure I can put I can do a macro or something. I don't do macros. Brother, what the hell was that? No. All right, this will become the CDI. Well, I can at the very least. Okay, I'm good. Do that and call this. You know, it's a lot easier if I just do it like. I can simplify this code a little bit by writing like this. If no code CDR PTR, then we're going to create it and assign it. And then we're just going to do that. A lot simpler. So else, if we don't have this, all right. So the language should be able to build itself pretty... What is your problem? I must have skipped a bracket somewhere. Yep. Okay. Hope you're having a nice day too, Miko. Okay. So the logic here is when the interpreter, or really the processor here, the alternative IR generator is what this is really, finds an S expression, it is going to create code or create a structure to hold that S expression. It is then going to evaluate it using the entire function. It is recursive. And then its output is going to be put into the current S expression. So that's going to allow us to chain them. But if instead it has a token, which is essentially an atomic value, that's the cool thing. We get that for free. Detection of atomic values. Very, very easy. Then we simply pass it on to the current S expression to, add it to the expression. Now, technically, expressions can be... I'm making them very recursive here. This is going to be very chained, similar to this, but without all these elements, essentially. That's the cool thing about it. It's going to be a lot more structure and a lot better in that sense. And yeah, when an S expression needs to chain a token, the first thing it's going to do is, do I have a first element inside myself? If not, I'll just add it as that. And I added for convenience 2 variables for a car, one that is a token, one that is a sub-expression. Otherwise, if there's already a car, a first element, then we're going to give it to the second element. The second element is going to do the same process. If there is no second element, we're going to create it. And that one is going to do the same processing. Do I have a car? If not, this is the car. Do I have a car? Yes, then go to the CDR, defer to that. So that way it's gonna allow us to chain things together in a relatively simple manner. Oh my god, I don't know what's wrong with me today. I genuinely cannot speak. Oh, and the same thing that happens for tokens also happens for subrules. Do you prefer programming while streaming over programming in isolation? I used to stream programming to myself in private streams because I could talk to myself about the problems I was tackling. I do find it easier sometimes. If I'm doing something relatively simple, I can easily do it with music in the background or YouTube in the background or something in the background or just whatever, a little bit of distraction. But if I do need to concentrate and I don't have those things, maybe music, but not other things, talking about it does help, but you don't need to do a private stream. You can just talk to yourself. It's okay. As long as you don't hear voices in your head, it's totally fine. If you do, contact a medical professional. But yeah, I have. It helps to explain things. We used to call it rubber ducky debugging before it became Ask Claude about it. You know, the only time I've ever seen an actual rubber duck is that fuck-ass store that all cities have nowadays, at least in Europe, all the cities have it. Rubber duck stores. There's one in Madrid, look at that. Fuck right off. Actually, I know exactly where it is. This is literally the only place where I've seen a rubber duck in real life. And by this, I mean this, because I've never gone into one of those places and never will. Why would I do that to myself? But yeah, that is a very well-known technique for programming, is you explain your code, and that helps you reason it, and it often helps you find issues. You know, you can do it on stream, you can do it talking to a rubber duck, apparently. You can do it talking to your dog. Never done that, actually. You can do it talking to yourself. You can do pair programming is kind of that as well. Talking to another person. Yeah, I think it's a very common thing. Okay. So, do we have a Lisp, again, not interpreter, but an IR generator for the interpreter? It's a chain IR more so than anything else. So we have that. Do we have it or do we crash? Well, we don't have it because I forgot to add it to the imaginal.c. Why are you not giving me an error? Why are you calling eval? Where are you getting eval? There's no eval any. Oh, there is. Technically, I haven't renamed this function. So it still thinks there's an eval, but there really isn't. Fool. Alright. Now it has an error, okay. It is now called walk AST. I'm gonna rename it as well. With a depth of -1, and we're going to need to have an S expression code root. That's gonna be the root of our program. And we're gonna sexp init. We're gonna initialize it, and we're gonna pass it in here to be populated. Is there something already called root? Ah, no, I just need to make it a code gen. And pass its pointer internally. In March or so, Gemini always wrote quack. It wanted to be a rubber duck so badly in almost every chat. Thanks for joining, Meko. See ya. Who uses Gemini for debugging though? Like, don't do that. I mean, for programming. Don't use AI for programming, but also definitely don't use Gemini. Okay, let me see if it crashes first. Sounds like a no to me. Although, it looks like I forgot to remove one print, but I left another. Oh no, that's not good. I'm only seeing one print. How is that possible? I've literally changed nothing about the execution of the program. But do we have something? Let me see. My program should be very, very simple. Add 1 and 2. Okay. So if I did everything right, then we should have in the car the value token to slice code token. We should have add. We do not. We have nothing being printed actually. That's even more suspicious. What? I'm sorry. You should be printing something. Okay, that prints. And then there's no return, but these prints never happen? But it doesn't look like we're getting stuck in this function. The program clearly quit. I'm assuming it crashed and I'm not seeing that. That's probably what's happening, yes. Alright, so that's probably a build system issue. Red build. Call a function called run. That function is here and it ignores error status, but it doesn't output error code. Error output T. So it's probably crashing. What's the name of it? Cred? Bro, what? .elf? Okay, it's .elf. Okay, it's crashing. I used it for trash talking. I could trash talk big software companies. Oh, I bet. Too bad it, directly benefits them. What's the syntax of the fuck-ass? This, I believe. Okay, it's segfaulting in register lm, but it cannot tell me where. Because I didn't compile with debug flags. Oh my god. Fucking weak ass. My language could tell you. I mean, my operating system could tell you exactly why it's crashing. Sucks to be you, I guess. But anyway, in register element, here, this does create, yeah, it allocates a pointer when we call init, which is an auto-generated function, but it allocates a pointer for us, and it gives it these functions. All right, so we have a valid pointer. We're checking for the validity of this pointer. We're checking for the validity of this thing. It's not a pointer. Ah. There. This is why in my language I made it not, instead of just an exclamation point. Okay. There's nothing in the car though. Nothing happened whatsoever. Although, we're not printing these anymore. I'm pretty sure I need to call token to slice also here. I am. Okay, so that's not good. Okay, so it says that it's trying to register add 1 and 2, but when I look at the car, there is none. So that didn't work. There's no sub rules whatsoever, so we should be okay with just printing. Are you serious? So this should not be getting called at all. This one should work and tell us exactly what's happening. Okay, so it tries to register add. That's considered to be the car of the current element. That is good. Although, hold on. A sexp car. Yeah, I figured there is one sub-expression, which is the root expression. Like, when we open the parenthesis at the very beginning, this is a sub-expression to the entire program. So, it tries to register add. It's the first element of the sub-expression, so it registers it as such. Then it tries to register 1, it defers to CDR, and inside of CDR it becomes car. Then it tries to register 2, it defers to the first CDR, which defers to the second, which puts it in car. Seems like we've done linked lists in the language itself. To me, this looks good. And then, when we close the entire thing, we do a sexp car, but either there's a bug there or oh well, no, I'm just this is what contains my sub-expression. It's not very expressive to do it this way, but there it is. Okay. Again, the whole program is considered an S expression. So this is the car of the program. So if I want to get add, I need to do car. But we have it. All right, now it's not very clean code. We have to do car S, car T, and we have to do a cast. But we're going to create some helpers, and that should make it easier. But okay, I can get rid of these prints, and now we can start evaluating the program. Now we can finally begin our actual VM, which is capable of interpreting this expression, which is already chained, so it's already going to be very easy. which means my code should look similar to the original Lisp implementation, just, I'm gonna be so for real, uglier, because it is going to be in C, so it's gonna need casts and a lot of stuff like that, a little bit more verbosity. All right, anyway, so this is gonna be lisp.c. This is gonna be an IR generator for Lisp, which again I'm doing separate from the other one. I think I might keep it separate from the other one. And then you are now going to IR Lisp, and also in the build system. Yeah, no, actually that stays the same. Cool. All right, so now I can start making the virtual machine. The code and the data are the same thing in Lisp, which means the code and the data are the same thing here. And the code is literally this thing. This is the code and the data. It holds all of it. I don't technically need to make it a proper virtual machine. I don't need it to have any kind of VM is actually a strong word. It's not going to be a VM. Again, what's the entry point? We start with an apply. We start with an apply. Okay. Okay, now we're actually getting to it. Now we're actually getting to eval and apply. It's finally time. Sorry, it took an hour and 41. Okay, not too bad. Plus yesterday's stream, but I was doing a whole bunch of side quests there. Okay, so we are going to run apply on this on this expression, and likewise we're going to be defining eval on this sub expression, which contains all the arguments. It's a little bit weird, but it's fine. Okay. We need to include IR general. Not sure why I called it general if then it contains 3 different languages of IR. Yeah, compiler is due for a refactor. I'm currently refactoring the scheduler of the operating system. Didn't work out. The first rewrite I did almost got it working, but then it was like, yeah, no, I would much rather do a more progressive one, little by little, making sure that everything works instead of the massive changes that I made. So I'm gonna finish that and then I can get to reworking this thing, but everything's gonna work so far. It's time for apply and eval. All right, and this is where I want to copy the code from Mr. McCarthy. This is eval. No, this is apply. Okay, so this is the code for apply. And then we have the code for eval. And then there's a bunch of helper functions that I'm not even going to define in the header of the thing. They're just helper functions. So we'll get to them. All right. So what do we need to do in apply? That's the first one. There's 3 possibilities. If it's an atomic, if it's a lambda, or if it's a label. All right. So the first thing we do is check if, the first thing we need to do, again, this is where the code gets a little bit ugly. Pointer, and we do want to null check it. You didn't consider that one, did you, McCarthy? You didn't have the casts and the null checks, did you, McCarthy? Not a real computer programmer like me. All right. First thing we're going to want to check, is it an atomic expression? If it is an atomic expression, we know that by checking, does it have as its first element a car? Well, not really, actually. There's even more than that. There's even more than that. If we want to do it properly, we're going to check the expression type against semantic rule expression. If it's not equal to an expression, then that is an atomic expression. So this is the atom. Otherwise, we're going to do this. We're also just going to do the null pointer at the beginning because we do need to do that. All right, and then here we're going to check, is it a lambda or is it a label? And we do that by checking the car of them. So it is treating the car as a token. I hope it is a token. So I believe if it doesn't have a token, that is a problem. But I'm not entirely sure. So yeah, I'm just gonna... Okay, I'm gonna also print some errors maybe. Null pointer. Should I make... you know what? There's gonna be a side quest in which I make the printer for this thing more formatted, because I've been wanting to make a proper log formatter for a while. This is gonna be my excuse to do it. All right. Yeah. So for now, I'm okay with just a very ugly error like this. Same thing is gonna happen here. No car for apply expression. All right. And then we're going to check simply the value of this thing against lambda and label. So token to slice, and then we can do a slice literal match s against lambda. Okay, when it comes to language today, I'm not doing good. I cannot speak, I cannot type. So bear with me. We're gonna make it. I also cannot reason. I forgot the name of this thing. Case insensitive, not just insensitive. It's not gonna be insensitive. It has a little bit of empathy. Okay, so if we're gonna handle lambda case, and the opposite, it's gonna be label, and those are gonna be the returns to the function. I feel like perhaps this is gonna need to return a code gen. Alright, that would make sense. Because what I'm doing here is transformations, essentially. So yeah, I'm straight up rewriting the compiler architecture that I had into, for Lisp. I had an IR generator, I just made an IR generator. I have a code transformer, I have a code transformer that just so happens to actually be evaluating the code. So, yeah. It's gonna need to return, but cannot be bothered right now. And here we have yet another error case. Unknown type, unknown expression in apply. And I can actually tell you what kind of expression that is. So we make the debugging a little bit easier. One of my biggest issues with the sabbatical is how hard to understand it is. Although it does have somewhat helpful error messages once you get past the fucking core dump that it gives you. Linux doesn't give you a core dump at all by default. It gives you too much. There's a middle ground there. And we're also gonna return. Now there is one thing that Lisp has that we don't have, and a lot of modern languages have. That is an error return, which is going to automatically exit the program. And that's pretty nice. We don't get that in this section, in this part, but we will get it in the actual language, so that's nice. Because you just interrupt the machine, you just stop it entirely. But that means we need to explicitly return here. You've been using Ubuntu GNOME, if I'm not mistaken. What did you switch to? I'm on Debian KDE now. Ubuntu unfortunately died on me. And by died, I mean it updated itself, and by the time the computer restarted, I no longer had a network manager. Don't worry though, you can download one. You can manually configure a network, and I did that, but I just used that to like transfer my stuff out of the computer and then install Debian so that this doesn't happen again. For the love of God. It pisses me off when I think about it. This is the second time it happens, by the way. Second time that Ubuntu breaks in this manner. Alright. I haven't actually implemented any of the interesting stuff, which is the actual stuff here. But again, that's why eval and apply do need to return stuff. But we'll get there, we'll get there, we'll get there. Right now I'm writing the skeleton of the function, then we'll write the meat of the function. Alright, what if the expression is not an expression type? That makes it atomic. Right, so we've gone so far that we're now evaluating the specific tokens. Can my language even fucking do that? No. No, it can't. I mean, not my language, but like the way that I structure the thing. Let me see. Alright, I think this condition is the one for this. Like, so what the code that I was writing at first was correct, but then I changed it. I don't know, let's see. Let's see, we're gonna try to run this thing. Okay, common sounds exactly like the kind of thing that should be at the top. Include network manager is terrible. The fact that we even have an opinion on that tells me a lot. You know how against this kind of stuff I am. What did I call? Oh, just apply. Just apply. Apply root. We have apply. Officially. I'm in the sabbatical. No car for apply expression. That is exactly what I thought would happen. I have to say I didn't know exactly what would happen, but yeah, I kind of expected that. Okay. Why? Because the root of my expression is first off another expression. But second, even if I hold on, let me do it right. Just pass it the actual this instead of the whole program, right? Because this is passing the whole program. I want to pass it just this expression to test my theory properly. So let me get the code that was here before. It's kind of what I need. Come on. This ugly thing. So I want to apply. Well, really all I needed to apply was this. The first sub-expression. Unknown expression add in apply. Yes. Okay. I was right. Now is the result that I was expecting. Okay. This case will never happen. Everything is expressions. This is what I should have checked for. So I was doing it right the first time, then I second doubted myself. Not a second guessed, I second doubted myself. And yeah, let us hear. Alright, so let's rewrite this thing. If no code return, well, actually, that null pointer, bada bim. Alright, we don't have anything in the atomic expression, so we can check it here. Atomic expression in car as B, code car T, token to lisp. There we go. All right. We will not be handling this situation for now, for the simple reason that we don't have a sub-expression as the parent. That this is not something like this. That wouldn't really make sense. This would be more for metaprogramming cases, but yeah, I think anyway. But it's not a lambda that I'm trying to apply or anything like that. But either way, I do have to write it properly. So if we don't have a token, aka an atomic expression, or an S expression, no sub-expression. Well, would this be an empty sub-expression? Empty S expression. Is that an error? That's not an error. That would just return nil. Okay, so I'm gonna mark it as P for placeholder, empty. So S expression. S expression. Why am I calling it that other thing? Love of God. Okay. So yeah, empty S expression here. Then here we have no, you don't access that. You need to access the car of that sub-expression. So you need to get that. This here is going to be the car. If you have no car, well, we've already null checked it. So yeah, let's just to write it a little bit better. If no car. All right, if we do have a car, we check the token value of that. And where is it? if there is one. If there isn't one, should this be an error? I feel like, yeah, but I'm not sure why. I feel like, well, it's probably a case that doesn't happen. Yeah, what if the sub-expression has another sub-expression? That cannot be nested? Yeah, that doesn't make sense. It cannot be nested. No atomic expression in sub-expression. These messages are not very easy to understand, but yeah, this one is. But yeah, I'll get to them. Anyway, no atomic expression, then now we can do this. Check if it's a lambda, check if it's a label, check if it's something else. Right, no, you can't have nested sub-expressions as the first expression because you can only have lambdas or labels. It doesn't allow nesting in the first. You can't do this. I think you can't do this. I don't think it makes sense to do this, so it doesn't allow you to do that, I believe. Okay. First introduction to it existing was fixing my server. A server my boss installed. A sec poll he wrote dictated that we'd have a minimal install on servers. The server he installed was a fat Ubuntu desktop. I was cleaning up the install and I discovered that if you uninstall Network Manager, it has a hissy fit and disables all network interfaces. Essentially, yeah. But the fact that it happened with an update was so ridiculous. Like, people really are right about Ubuntu being the Windows of Linux. Because last year, Windows was pushing a bunch of updates that were breaking the system. And Ubuntu has also been pushing updates that break the system. So, good job, guys. Really, really earned that label. But yeah, the first time it happened to me, I just reinstalled without even debugging what the issue was. The second time, I had been coding for like 30 minutes when it happened. Or when I realized I didn't have network. So, I really didn't have network for a while, but I didn't realize until I was going to look something up, or I was going to push my changes. And no, I was gonna look something up, yeah. I didn't have network, so well. My favorite Windows feature is when it decides that rendering fonts is an optional capacity and it has until reboot. You trying to read text? Oh, for Copilot, yeah. Oh, no, that's actually, yeah. Oh, sorry that happened to you, man. Couldn't use Copilot. It must have been agonizing. Atomic expression in car as add. We have an atomic espressione. Un'espressione atomica. Very good. Stopped rendering all text. No, I get it. But then if it stopped rendering all text, then you couldn't talk to Copilot anymore. So I understand your pain. That must have been horrible. Sorry that happened to you. Okay, we have our atomic espressione. And with the atomic espressione, we can now make a hard-coded plus function. There is an ad running on Twitch, but sucks to be you guys. Again, I'm not really gonna be doing returns yet. But you know what? I do need an adder as an atomic expression, don't I? Hold on. I have a question. Do we have any Lisp experts that can tell me, that can point me to the implementation of the plus function in any language of Lisp, in any dialect of Lisp? Because that would be great to find. That would be great to see. There are no companies that don't use Windows. No. I want to see how you implement an adder with just these things. That seems like an interesting thing because I can easily do it. But it wouldn't be as fun. So if we have one, I would love to look at it. But anyway, I am going to be treating add as a built-in function. Now here's the thing. One thing that I don't think I have mentioned on stream officially, but I have mentioned it inside of my head, is the fact that I would want this to have C interoperability. I want this to be the language my terminal speaks. I want this to be the language my Emacs replacement speaks. I want this to be the language that the gods speak. I want this to be the language that everyone speaks. I want this to be the language that my games scripting speak. So by the way, I have to say, I'm gonna out myself for no particular reason here. But I want to show you the setup script for a very simple game based off of levels, 5 days. I have not really bothered doing it properly. So I haven't done scripting. Everything is done in C and it's ugly as shit. Look at this. How many lines? 800 lines? That is so much less than I expected it to be. I don't want Lua, I want Lisp. I have to say I've never done Lua, but I've seen what Lua looks like. I don't know. I think I maybe would have done some game modding if it wasn't done with Lua. Nothing about Lua ever seemed appealing to me, so I never learned it. But it is nice. I don't have anything necessarily against it. But I want a scripting language, and yeah, I want Lisp to be my scripting language. Anyway, this is the setup script. It's not even the worst. I thought it would be like at least 1,000 lines. It's not even 800. It's not even 900. But because it's C, for example, like I said, it's actually like 5 days, like 5 tasks to complete on 5 days. So each day is set up 5, 4, 3, 2, 1 because they're all chained together. So when day 1 completes successfully, you go to day 2, which means day 1 needs to have a reference to day 2. I didn't want to do a whole lot of forward declarations, so I did 5, 4, 3, 2, 1. And even then I had to have some forward declarations. There's game input in here. There's all of this like set up the world, set up the engine kind of stuff. Create evaluators. This is setting up the very basic entities, which is just like map and the player. No, just the player actually. The map gets set up by the create map function, which is going to be up there. Then there's day 1. Whoops, just move some stuff around there without noticing. Then there's day 2. We're now on to day 3, day 4, day 5. Day 4 is a simple one. Day 5. And then up here we have a few helper things. Now characters that are introduced in day 1 but are used in all other days are also found here. What is this? This is create character, helper function. This is create map, helper function. Some other helper functions, and then we get to the million includes. Just wanted to out my horrible code. It actually was less horrible than I thought, so whatever. Alright, in the meantime, Fuss Unleashed came through with the implementation of line 600 to 741, the implementation of add. 600. Okay, here's their whole eval. So here they have let, set, if, fun, while, quote, and, or, do, cons, car, cdr, set cdr, list not is atom print. Where is add specifically though? Is it not considered a built-in function? Well, 741. Oh, okay, I missed. I stepped over this. Arith hop. Arith hop. No symbols found. Then it finds it. Is just a null. Not a null. What? A loop. Oh my god, I cannot speak today. Fuck off. It's taking a number x and then performing x operand and then eval arguments. So I'm assuming this just gets the next one. Okay, so it's kind of a hard-coded C implementation of add, which is kind of what I was gonna do. Okay, I guess that works. I like that they're using macros, by the way. I didn't even what's happening to me? I'm not using macros as much. Since Lisp, I don't need to meta program in C anymore. Lisp has ruined me as a C programmer, I have to say. I still like C, but I don't love C anymore. I love Lisp now. Let's call it polyamorous, but like, I don't know. A tiny embeddable language implemented in ANSI C. Interesting. It's not even considered a Lisp language, though it is. Interesting project, by the way, because I found that code very easy to read, and that's usually not the case. It's usually not the case when I read other projects. This was so easy to... Obviously, yeah, you pointed me exactly to where I needed to go, and then GitHub actually worked with the symbol resolution. But yeah, it's easy to see what's happening. Okay, so this is doing toNumber on... Actually, interesting that eval arg... Oh, calls next arg. So it's literally just a loop. It doesn't resolve it in a recursive way, it resolves it in a looping way. But okay, no problem. All right, we're going to then add a built-in adder. And then, yeah, with some metaprogramming, it should be possible to do the same thing that they were doing and make, you know, instead of a void function, make it a macro and be able to add multiple symbols. So add, multiply, divide, all of those. Although what I was interested in is the implementation in Lisp itself. You know? Can I dig around and find it in... Is SBCL open source? Like, I want to see how it's implemented in a Lispy manner. Projects page. Okay. No, I'm not sure if this is what I want now anymore. It's not. This is a SourceForge. Never mind. Well, there's a mirror on GitHub. And where is your built-in library? That's what I want. Wait, is that line 600 message old? Oh, yeah, it's for array top. Okay. Benchmark, contrib, cross-build runner, doc. Not sure what that is. Tools for build. Okay, what about, oh wait, hold on, there's a bunch of Lisp files here, but not what I'm looking for. All right, I'm interested in finding out how Lisp implements add in a purely Lispy manner, right? I only have apply, eval, and their helper functions. How do I implement add? I can technically figure that out myself. I can do an experiment, but I cannot be bothered right now. All right. Again, with no return values, this is a good place to put returns, but we're going to make a string slice. What did I call it down here? S. So I call it the same thing. And then we can do a if slice lit match add true, then you're going to call imaginal built-in on this. Okay, and there's no more built-in expressions right now. There's only add, because I want to hard code the behavior of add. Okay, so to do it, first we have to get the car. So maybe we want to do it safely, right? If code carty kind, if code carty kind, then A is going to be equal to the parsing of our string as an integer, and another thing we'll need to handle is sub-expressions in car, because that technically can happen. Right here we are actually allowed to do add where we will need to resolve add 2, 3, resolve add 3, 4, and then resolve the entire thing. But we are not handling that right now. Either way, the child of this will be a sub-expression, which will require evaluation in and of itself. But since I want to hard code its behavior, we're going to I64b equal to 0. If there is no car, then we're actually not going to return. B is just going to stay as 0. So if there is a car, we're going to assign B to I didn't do it like I should have. That is it. And then we just print add I plus I equal to I, A, B, and A plus B. And I'm also going to add a to-do. Sub-expression in CDR. Oh, but no, this should be CDR. Okay. Is that enough? Am I really adding 1 and 0? I'm not. That's not good. It read the 1, but not the 0. Yeah, so it's off. It's a little off. Well, yeah, because what I need to do is pass it the code CDR as the expression. There we go. 1 plus 2 equals 3. Okay. And we have our first our first operation in Lisp, which is add. First and only operation in Lisp, which is add. And we also don't have return values, which I'm gonna be honest is making this whole thing a little bit harder to work with. So it is time to add returns to this whole thing. Because again, this should return, and that should be what we print, if we choose to print, if we so choose. Okay, so probably the easiest one to do a return with is going to be a code gen for add. We can return an empty. We're totally fine doing that. Well, no, we should return an empty sub-expression. Although I do have to say this is Z allocating. Maybe I can optimize that internally, but it's not of our business right now. All right, so if we have a null pointer, then we just return an empty sub-expression. No, for that matter, we can actually return an empty sub-expression. Completely empty. Okay. Then here we can return a sub-expression. This is so not idiomatic, but again, a macro will fix it. Or not even a macro, actually, just simple sub-expression that takes in a value. Now, the thing that's a little bit is that I'm only allowing token values. That isn't great. I should probably use better typing for this. And I can. Because here I'm using specific types that the IRGen understands, CodeGen, token, and whatnot, but nothing prevents me from using an int or something more complex. I'm gonna hard code it again. Gonna be doing a lot of cleaning up of this code. Try to look up the plus function in chicken scheme. It looks like it's implemented in at least 30 C functions. Christ, that's not necessary. What's my favorite programming language? Now it's between C and Lisp. That's between those two. Swift is also honorable mention as a good mix between the two, I have to say. But the syntax of Lisp is just so simple. It's just my theme is Synthwave 84. That's what it's called. Okay, so yeah, I should do better typing here. And also here, where I get the atomic value. I just, how you say, cannot be bothered. Not right now. It's getting kind of late. Maybe it's time to call it after this and do a proper clean and maybe a midweek stream to continue working. Since I did apply, now it's time to do eval. Maybe tomorrow, maybe Wednesday, I don't know, but I am excited to do this, so might as well stream it. Okay, then there's not really much of a point for me to do the return thing right now. Instead, it's better for me to do it properly later. Right, so we have that. We have that. We have the overall logic. Yo, Stony, what's up? Have you ever looked at C macros? You got to use Lisp for macros in C. Ooh. Damn, they got ahead of me. What do you think I was trying to do here? C macros. Alright, are you stupid? Are you doubly stupid? Well, it would be stupid if machines were capable of having intelligence, but they're not. So. My God, how many times I have to tell you, trust me, I know what I'm doing. Thank you for the link. Avoided a crash out right there. Okay, so just to wrap up what we've done here, we've implemented apply. A very basic version of apply, but we've implemented a very basic version of apply that is good for me. I like that. I like that. Again, the cool thing about doing it with this code gen thing here is that I don't really need to allocate much. There is allocation happening, but like, I handle that. It's not a problem. And it is very similar to what we have here, just with C. So it gets a little bit uglier, you know. But essentially, the first entry point into our function is going to check our function for something like this, right? An identifier here, and then arguments, one or more arguments. Doesn't matter how many arguments. That's what CDR is for. If the first thing is an identifier, then it just treats it as a function call, right? We're trying to call this function. The first thing it does is it one of the built-in functions? If so, call the built-in function like we're doing here. We have a built-in for imaginal called add. If it is not a built-in function, then that's the part that's currently missing. That is this part. It is going to first evaluate the function. So eval ID, which essentially just means look up the symbol, find the code that belongs to it, and run that. Or use that, and then recursively call apply using that code and the arguments to apply the arguments to the code. Then there is the other option. There is two cases in which the first argument here is not going to be an identifier. Two cases in Lisp 1.5. Maybe newer ones and dialects and whatnot have more. We're implementing Lisp 1.5 and then we're going to see where we go from there. The case of lambda, which is the anonymous function in question, and the case of label, which is a function declaration, if I'm not mistaken. So that is handled by this, which we haven't written any code for, because we don't really have to deal with that for a little bit. Okay, so that is our apply function. Then there is the eval function, which is even simpler. Eval is going to take two elements, element 1 and element 2. Then it is going to check what that first element is. So this is going to take this is going to actually run the function, whereas the other one like processes the function. This one actually evaluates the function and gives it a result. Whereas apply applies, this eval evals. But I'm glad I'm understanding these functions. So I'm doing a little recap at the end. Anyway, eval is going to run these functions. Again, much like there are some built-in functions, there are some built-in forms, is what they're called technically. So they're not functions, they're forms. Quote, which escapes an expression, and cond, which evaluates a condition until it finds evaluates conditions until it finds a true one, and then applies returns the result that was supposed to be returned if the condition was true. So if then returns then if is true. And if it doesn't match this condition, then it just applies as well. Is this the same exact call? This is the same exact call. So whether the first element is not an atom, so it looks like this, or whether it is neither quote not cond, looks like this, for example, then it calls apply on it. Okay. Then there's again the helper functions, evcon, evlist. We're gonna need a few more helper functions, but this should do the trick. Now, I'm going to want to do, of course, a couple of things to my compiler to properly adapt it to this. First off, I'm gonna want to give S expressions their own semantic type so that the compiler understands what an S expression actually is. Which, if I ever want to, what is it called? If I ever want to be able to do something with, compiling instead of interpreting, maybe that's gonna help me. And types, because right now I could return the value of, an addition between 1 and 2. That's 3. We literally have it here, but I have nowhere to store it. So I'll have to do that. And the main reason I haven't done it is these checks will get a little bit more complex, and I'll need to write some more boilerplate and scanning late, and I don't want to do that. All right. Either way, I do want to finish a few things before I finish the stream. First off, C macros. I want to see what they look like. This I wouldn't call this Lisp syntax. I would call this more so declarative syntax, which makes sense. I've done some declarative syntax in C with macros as well, for that matter. Barely use it, to be honest, but like in my layout system, you do vertical. Well, no, I do use this a lot, actually. The problem is you need to do it like this. It's not super elegant. I'm sure I can maybe clean it up a little bit, maybe even make it look like this, because you can technically do this kind of thing. But interesting to see. Are they actually like meta programming? That would be nice. Well, this whole thing should allow me to do meta programming in C. Actually. I could make Lisp the meta programming language of CRED if I wanted to. It gets interpreted, and then the result just gets put alongside the C code that gets generated. I'm getting a little ahead of myself, but technically I think that's a thing that I should be able to do. Do I want to do it? I don't know. But I'm talking actual Lisp in the language. It's not half bad. Okay, enough of that. Enough of that. Now. There was one more thing. I don't remember what it is. Doing some final touch-ups before releasing V2 of my player libraries. Nice. Bye, Fuss Unleashed. Oh, what is that poster? That is the beautiful eval apply. Might as well bring it up. The beautiful eval apply. It's the cover of a Lisp book, which perfectly explains the eval and apply functions that I'm doing right now. I did apply. I need to do eval. Isn't that beautiful? But since I don't have a poster, I just put it up on OBS. Better than the picture of Brendan Eichner. Brendan Eich that was there before. So I don't know. I prefer that. Here's the thing. I kind of forgot how meta-programmy I could get with this code gen shit. If I do a few more macros and whatnot, I should be able to get pretty meta-programmy with them. Like I'm doing here. Because I'm literally manipulating the language itself to run the code. So I'm actually very, very glad that I did the interpreted thing. Or that I did this. Well, I'm manipulating like the compiler's internal IR to do the actual code. Very meta-programming stuff. But Lisp is very meta-programming. So it makes sense that the Lisp interpreter would be meta-programming. Now, there are a few improvements that I want to make. There are a few, like, mostly one thing that I absolutely should do is make all these code generators that are currently just using zalloc use the same allocator, but with a dedicated page just for them. That should make them a lot more efficient, because any other allocations the compiler is doing will also go in here. I shouldn't be doing any other allocations, but just in case, I have a page just for this, which is essentially, this is handling the memory of the program. If I make it in a arena type of way, if you want to get blanking on the name, if you want to use modern lingo, if you make it in an arena type of allocator, it is essentially just a heap. Just a very neatly arranged heap for the virtual machine, and a very meta-programmy language for the interpreter. So essentially it's a VM, but not really. It's not a virtual machine, it's an imaginal machine, because it's not real, but it sure seems like one in terms of how you work with it. You write code directly by talking to these code expressions, and it allocates by itself. You don't have to deal with that. It should also do garbage collection. That's a thing that's going to be interesting to handle, but it should be able to handle it. So, anyway, Now I like the name Imaginal VM or Imaginal Machine a lot more. Simply because I can code it like a machine, but I don't really have to do a proper virtual machine. So it's not a VM, it's an Imaginal machine. All right, now I like it. What started out as a pun ended up being actually nice, so that's great. Okay. Coroutine library I use give me 256 kilobyte stacks, so I just put a ton of stuff on the heap allocated stacks. See, technically, because of the way my allocator works, I can almost guarantee you, and because of the compiler, the way that the compiler works, I can almost guarantee you that it's not doing a lot of allocations. The compiler is barely doing any allocations, I believe. And what it's not doing is cleaning up its own memory. So the garbage collection for the Imaginal machine is also going to help the compiler. That's going to be nice. All right. You know what? I don't mind. The fact that you program the fact that I'm doing Lisp with the same code or the same code that I'm doing C essentially. Like what I was doing as C transformations, which for example in my language I was doing stuff like lambdas. Ugly syntax, it's just functions without a name. I'll need to come up with something better. But anyway, the way that I'm doing lambdas in this language is literally taking this whole thing, which is the lambda, moving it out of here, putting it here, giving it a name, which is usually temp func 1, and then putting the function pointer here. So that's, I called that transformations in the compiler, but it is essentially what the same logic that powers this is also powering the Lisp interpreter. So I really like that. Obviously, there's a lot more rules to this than there is to the Lisp interpreter, especially right now when I've only implemented like a quarter of a function. But still, it is nice that I'm capable of doing that stuff. And I look forward to seeing how I can use it to my advantage later on. Again, if I put S expressions directly in the syntax of my language, I can do metaprogramming in Lisp in my language. And then I'll have a favorite programming language, the cred, well, cred actually, the name is gonna stay cred, but C with lambdas and slightly cleaner syntax and Lisp metaprogramming. All right, I have a new goal. I have a new goal for this compiler now. I was genuinely gonna let go of the language if I didn't find a use for it. Now I did. Closures too, eventually. It's gonna be very similar to what I just explained, right? You want to do a closure instead of that, so let's say that, I don't know, you want to capture y. There's a variable here. This code makes no semantic sense, by the way, but it doesn't matter. You want to capture y. Well, move this entire thing out. Prepare a temp value, assign y to it, then a temp function. Well, it would be temp value 1 also. Temp function 1. There you go. Instead of y, you use temp value 1. You declare that, zero initialize it. It also zero initializes everything, which C doesn't do, and it's really annoying. And then this one is going to be temp func1, and there you have it. Clang apparently offers closures, but calls them the extremely searchable name blocks. Blocks is what I call literally the top level of my IR for C. It's called blocks. By the way, another thing that I completely forgot is the fact that there are rules for parsing the language. So this compiler is getting crazy. I don't know if it's crazy stupid or crazy genius. I don't know if there's even a line, and I don't know how blurry that line is, but I'm definitely making it blurrier with this whole thing. Or maybe it's just stupid without the genius. I guess we'll see. But anyway, the compiler has somewhat dynamic language in the sense that you just... If it's stupid and it works, then it's not stupid. Exactly. It's experimental. It's experimental. Like the music that I make. Experimental. Not shitty. Experimental. Yeah, so this is the rule parser, which is also due for a refactor, but now really important. Because it's going to be so much easier to refactor once everything starts coming together. It finds this file, parses it. This is a much more traditional parser instead of the more generic parser that the compiler itself has. And it is able to generate this rules.c, which is just a bunch of structures, C structures and arrays, that explain to the parser how it should parse your language. Right, so we have, this is the Lisp one, actually. We have 5 different grammatical rules. We have chains, expressions, S-expressions, arguments, and atoms. I have to change the name of these two, by the way. But anyway. An atom is made up of one of these 3 rules. If this one doesn't match, then the next one. And these rules are made up of sequences, except they all have one element in the sequence each. This one, for example, has 2, right? If you find an identifier, which is taken from the tokenizer, tokenizer gives me an identifier, something of type identifier, boom, this rule matched. If it gives me a string, so already with the quotation marks instead of it, matches. If it gives me a number, matches. All right, simple as that. And then also I can do typing by checking this, just the type of the thing, which I probably plan on doing tomorrow or after the stream. I don't know. But the way that the rule generator does this also uses, it doesn't use the compiler itself, but it uses the IR. So it uses the kind of meta programming shit that I just did, which has its own rules for it, which are these two: a sequence, a rule sequence, or a rule entry. So entry is those 5 things: chain, expression, S-expression, atom, all of those. And the sequence is just like parse an identifier, then this, then that. And no, that's not quite right. Right, this one indicates one of the options, and this one indicates the sequence. That's how it is. And then all of that gets wrapped in a block, which is this thing, which has a statement at the beginning and then the next block after it. Very meta programming as well. I hadn't even thought of the fact that technically that is also an imaginal machine, which I've now officially, I'm gonna begin calling them that. Imaginal machines. The whole thing didn't definitely come from the fact that I wanted to call my dialect of Lisp imaginal Lisp. Definitely not that. So the whole point of this is that you can technically mix, if you want, the syntax of any language that you want, but with the functionality of a Lisp language, a C language, and a rule language, which looks like this. Bye, Ivan. See you. By the way, to Spanish and Italian speakers, I usually respond in English, but I do occasionally curse in Spanish when things get really buggy. But besides that, in the chat, I usually will respond in English, unless absolutely strictly necessary. The insults in Spanish add a little bit of spice to the whole thing. Unfortunately, the type of insults that I like in Italian are a little bit too strong for YouTube and Twitch moderation. At least from what I've seen other Italian YouTubers do. Anyway, this can also be part of the same language. And I was just talking about doing string manipulation. The fact that Lisp is really good for list manipulation, but really bad for string manipulation. It doesn't really do string manipulation. C is not really good for string manipulation. And last week I was asking, is there a programming language that is really, really good at that? I don't mean in the sense of its library, it has a really good library for this, because at the end of the day, all of them could have a library for it. It's just a matter of like the language itself was built for string manipulation, and therefore it has really good native programming for string manipulation. Like Lisp, a lot of languages can handle lists pretty well, but Lisp is a literal language built around lists entirely. So that, but for string manipulation and for like pattern matching and whatnot. Someone mentioned regular expressions, and yeah, technically, yeah, you're not wrong. What I hate about them is the rule-based, I mean the syntax of them. It gets unreadable fast. I made a regular expression parser a bit ago, because they are useful for doing that, for detecting specific substrings and whatnot. They're useful for that. So I made a very simple one, which by the way runs in its own finite state machine. Wouldn't it be nice if you could do that kind of finite state machine also in this compiler? It's a very simple type of state machine that just has two states, true and false. There's a condition. If the condition is met, go here. If it's not met, go there. Literally that easy. Doesn't need anything besides that. Hello, Madzini. Madzini. At this point, I'm just trying to throw everything into the compiler and see what comes out. See what kind of meta-programming BS I come up with. But anyway, yeah, like even the most basic regular expression, which is supposed to match this kind of pattern, by the way, and also this kind of pattern, looks like this. This is unreadable. This is absolutely unreadable. Granted, I'm doing it in C, which requires me to double escape, because I need to escape my escapes, so that the processor actually sees them as escapes. But it's still unreadable even without that. And this is a simple one. So I wouldn't mind exploring more languages. Like, even that, is that clean? No, I don't think C handles R. I didn't even know that was a thing. That's how little C I do. Some languages do this, some languages do this, but no, I can't really do that, unfortunately. I do wonder if macros maybe could help do that, at least auto escape, but we just saw what it looks like even when you have just one escape. It's ugly still. The underlying logic I think is really good, And I particularly like the way that I built my finite state machine with just two states, because the explanation that Wikipedia has going on is genuinely nonsense. Mathematical, no, it's math slop. It's just math slop going on here. Like, just looking at this, I don't understand what's going on, because you have like this symbol and this symbol are the same one, so how do I know which is which? Um, but it is comprehensible. It's not like this is an ambiguous language. It's just hard to read. Um, but yeah, this is the finite state machine, which, by the way, like actually detecting the character happens one step. It has more states than mine, and I find it more unreadable than mine. Does mine actually still print? No, it doesn't. It doesn't do that anymore. It used to print a debug view of the state machine that it creates, and it's very simple. It's just try to find this character. If you find it, then try to find this character. If you find it, then try to find any character that isn't this one. How many times? 0 or more times. Which 0 or more is represented as try to find this character 0 or more times. If it succeeds, then go to self. So try to match again. If it fails, go to the next node. Literally like that. And actually, I moved it into a stack-based type of thing, so now it's just 0 and 1. Advance to the next state or stay in the same state. Literally that simple. It's R. No, yeah, if you can't put an R in front of it, then no matter the syntax inside of the string. Yeah, C doesn't really have strings formatted like that. What is that character? Like a skinny space. I don't have a skinny space. That's the difference. Okay. That looks like pain. This is regular expression. It's just double escaped, so it gets uglier, but it is ugly. I have to say, as a concept, regular expressions make a lot of sense, and the finite state machine that I built should be able to handle things pretty well. It also should be able to handle like you got this. It also should be able to handle Christ. Capture groups. It should be able to handle capture groups. I've not been very eloquent today. I never am, but today especially has been really, really bad. Yeah, it should be, it does handle capture groups. I need them for this. I am using them. But yeah, like I did this with regular expressions for a markdown thingy. But then I was like, okay, I would have to make very similar regular expressions for parsing the rest of markdown. That sounds like such a pain in the ass. Although, if I do it with a slightly better language, like a better interface, where regular expression is the interface in the finite state machine. Let me move that image, because like my hands are disappearing every 2 seconds. All right. If regular expressions are the interface and the finite state machine is the actual thing, replace the interface with something better, and then you get a nice state machine. And even this can work for how you should do these kinds of things. So I'll give it a little whirl. Although it would be really funny if the parser and regular expressions had the same underlying logic. That would be a little bit too crazy. Let me not go there. Okay. One other thing I want to look at, just for the sake of it. I don't remember about this. The rule transformer, does it create arrays? No. Oh wait, doesn't it? It doesn't. But it, whatever, doesn't matter. Okay. Well, that should be enough for today, although I did say I was going to explore languages, and I do remember I opened these two Wikipedia pages that are for, well, no, this one, nah. I opened one for a language called Snowball, here it is, which I found out about. It is a text programming language. I want to see what that looks like. So I only found out about it on Wikipedia. I don't even know. I was digging around. It's okay. This is a stemmer. So it kind of takes words and does stuff like runner turns into run. Running turns into run. I mean, I know it's capable of doing it. I just want to see what the syntax of the language looks like. But it looks very much just like a very similar to C type of language, or very similar to that kind of syntax. Nothing special to handle strings specifically that makes it elegant. Again, it feels like the thing that makes this language good at parsing strings is a library that it uses. Snowball stemmer, not the language itself. So that kind of, it's not what I was looking for. Somebody also mentioned awk. This is actually a Unix program, but I don't know what it looks like. Can you give me an example? It uses regular expressions. Well, well, well. Almost vindicated. Okay. Alright. So yeah, I feel like the kind of language that I'm trying to use or trying to build is not necessarily a thing that exists. This comes close, I have to say. I like what I'm seeing, you know. If a regular expression matches, do this. It is doing a little bit of what I was saying, you know. A declarative type of syntax for, is it considered declarative by Wikipedia? Not really. But yeah, from what I'm understanding here, if this regular expression matches, do this with the match of the regular expression. That kind of syntax I do like. Or at very least that kind of way of working with them. Anyway, that is enough for now. User interface for my video player is 4,500 lines of code. Oh my god. What language do you use for your interface? I have to say declarative interfaces, once you go declarative, you never go baclarative. Alright. It's a web player, so make a guess. Rust. That's your problem. Rust. I have to say, is it TypeScript? TypeScript has some okay-ish declarative syntax for UIs, but it's not the best. It's like the worst of JavaScript with the worst of HTML. Genuinely, what the fuck, bro? It does look nice, though, I have to say. I'm gonna steal your code real quick. Alright, everybody took screenshots? Alright, I'm closing it. Yeah, TypeScript, Well, I'm thinking of React, actually. It's not necessarily the same way that TypeScript does it, is it? Um, nah. Nah. Nah, no, 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 no. Look at this beauty. Look at this beauty. VStack. Boom. Image. Boom. Text. Boom. Declarative. Easy. Lisp can do the same thing, by the way. How amazing is that? Just literally, instead of brackets, put parentheses, put them here. Lisp can do it, and their compiler probably will not time out. This is literally the only compiler that can time out is the Swift one that I know of. That I know of. The only compiler that's ever timed out on me is the Swift compiler when I have a syntax error in Swift UI. I have to say, I like the language, but the implementation needs work. It needs optimization and it needs it fast. It hasn't happened in a while. Maybe they have optimized it and I just haven't realized, but I haven't done a lot of Swift UI, especially nothing complex, so I'm not sure. I'll follow next once I have the baseline done. Yep. Swift UI, I love doing Swift. I went from hating doing UI in iOS to loving doing UI in iOS thanks to Swift UI. It's declarative. It uses bindings. That's called like reactive program. No, there's a name for it as well. But yeah, essentially like when the data updates, you bind your data to your UI, and then when the data updates, the UI automatically updates. Forgot what that's called, but yeah. Anyway, all right. High chance of a midweek stream tomorrow or Wednesday. For implementing apply, since I did no, I already did apply to implement eval and also maybe finish apply. Yeah, in the meantime, I'm gonna be doing like better type handling. So I can technically do that, and I should do that properly, but uh, haven't bothered. So yeah, planning on a raid, sure. Though I'm gonna have to run. I haven't done one in a while. All right, we got an advanced C programming on Linux, designing and ISA implementing tools. Assembler, disassembler, profiler, and emulator. I kinda hate that I wanna run. That I need to run. I'm going to try to catch this a little bit. Because that seems like an interesting topic. Alright. Thank you, everybody. I'll see you tomorrow or Wednesday or Friday. Wait, hold on. I forgot that the raids take 10 seconds to get ready. So, stick around. Don't leave! Don't leave! Hold on! Hold on! Almost there! Alright. See you, everybody.